I want to make the remark that it is nicer to return the function in the same form that it was given after you've transformed it. Okay, let's take a look at the next page. And in this one, we're finding solutions to systems of equations. This is two linear equations. Substituting the 4x plus 3, because y equals 4x plus 3, I'm substituting that in for y in the second equation. I'm working it out to get x equals -7. I'm trying to be kind of quick through this. I'm replacing the x value in either one of these functions with -7. I chose the first one because it was set up to give me y right away. And I get -25, so there's my solution. So -7, -25. I won't have one on the test. You won't have a system of just two lines. It'll be closer to this one. It'll actually be a system of a line and a parabola. So parabolas and lines can cross in as many as two different places, like happened in here when we have two parabolas intersecting. And so since they're both equal to y, this is what we did. We replaced 3 minus x squared with this y, or vice versa. Anyway, we set the two equations equal to each other. I balance it out to get 0 on the left side. I know I've skipped a few steps there in that process, but I think if you'll see if you replace this y here in the second equation with 3 minus x squared, subtract 3, add x squared to both sides, and you'll get 0 on the left equals this new quadratic function 2x squared minus 2x minus 4. That can be factored down in a couple of steps, factoring out a 2 from everything, and then factoring the resulting trinomial there into two binomials like this to give us our solutions to this equation being x equals 2 or x equals -1. So I know that setting these quadratics equal to 0 is an excellent way to solve them, and I've solved it to get x equals 2 and x equals -1. Now that's just the x coordinates. I need to find the y coordinates also, where these two functions intersect. So when x equals 2, I replace the 2 in this one. I could do either one again, but I'm choosing this one because it's a little bit easier. 3 minus 2 squared gives me finally a y value of -1. So when x equals 2, y equals -1. If I replace the x value in this equation with -1, because that was my other solution for x equals -1. So 3 minus -1 squared, blah, 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 I get y equals 2. And so these are my 2 points. When x equals -1, y is 2. When x equals 2, y is -1. Just kind of a flip there. That's just a coincidence. They don't always work out like that. But it is important to make sure that when you find your 2x values, that you keep the corresponding y value, straight, so that you don't mix up the y values with your x's. Okay? I hope that's clear. Moving on to the next problem, finding all these things out for each one of these quadratics. First one, I put this into vertex form by completing the square. All right, I kind of like took this, moved the 3 over, all right, to get +3 here. I gave myself a little space. Half of this number, remember, it's completing the square. That little thing is b over 2 squared. That's kind of the magic little bullet for completing this square. So b over 2 squared in this case is just +1. So I add 1 and I subtract 1. That way I'm not really adding anything to that side of the equation. I could add 1 here and add 1 over there, and then later on subtract the 1. So either way, whatever way makes more sense for you. But anyway, we get this trinomial here. I factor it down to x minus 1 squared. 3 plus -1 is 2. So my vertex is at 1, 2. X minus 1 squared plus 2. That's vertex form, so the vertex is 1, 2. The range is from 2 to infinity, all right? It's a positive parabola because the x squared is positive, so the parabola is going upwards. And so the range is dependent on the y coordinate of the vertex. So from that y coordinate to infinity is the range of that parabola. As you can see by my little sketch here, it does not cross the x-axis, so there are no x-intercepts. So don't even have to worry about that one. The other one does, though, but let's go through that again. This is a more complicated completing the square process. I have to factor out the -4 from each of these two terms. Remember, you don't want to really mess around with the constant. So just kind of kick this off to the side for a little bit, give yourself some space, and factor out this a value from these two terms. Well, -4 out of each of those leaves me with x squared plus 3x. And then I have this little blank spot here. Well, this blank spot, that's where b over 2 squared comes in once again. And in this case, 3 divided by 2 squared is 2.25. So I'm going to add 2.25 inside the parentheses here. These parentheses, everything, as we mentioned, is being multiplied by this -4 that we factored out to begin with. So that -4 still is playing a role here, because when I add my compensating value here, I have to really think carefully. This 2.25 here is being multiplied by -4. That equals -9. So even though it looks like I wrote 2.25 in here, well, actually I did, right? 2.25, but I didn't add that. What I added really was -9 here. So I have to compensate that by adding +9. Okay, that's kind of a lot of negatives to kind of flip back and forth and keep straight in your head. So slow that down and repeat that part of the video if you need to. Anyway, I end up with factoring this trinomial here to x plus 1.5. Remember, this value is always half of b in every case. So half of that is 1.5, so it's x plus 1.5 squared plus 16. That's what 7 and 9 make. And so the vertex is at -1.5 comma 16. And the range is from -infinity up to +16. Remember, this is this parabola opens downwards. So it goes down to -infinity, and this 16 represents the maximum point, or the highest y value on the curve. And so that limits the range. So the range is from -infinity to +16. Now, to find the x-intercepts of this, what you need to do is you need to replace the y with 0 and solve the equation. It so happens that this quadratic does factor, but it's kind of hard to factor it, so I just took the easy route and used the quadratic formula here. So I'm putting in all these a, b, and c values into my quadratic formula. I'm working it out here. I get the square root of 256, which is 16. 12 plus 16 over -8. That's 28 over -8, that's -3.5. Or 12 minus 16 over -8, that's -4 over -8, which is +1/2, +0.5. So there are my two x-intercepts for this parabola, okay? And anytime that you do get a perfect square underneath the radical here when you're doing the quadratic formula, that means that you could have factored the expression. But sometimes that's harder. So I just did the quadratic formula here for that. Let's move on. Quadratic inequalities. Oh boy. So I'm once again finding the zeros of these quadratic expressions, okay? Quadratic equations. The zeros are what you get when you solve it equal to 0. And this one is, again, factorable. You can see I've factored out a 2 from all the terms, leaving me with x squared plus 3x minus 10. That factors pretty easily to x plus 5 times x minus 2. So my two zeros are -5 and +2. Now, this +2 outside the multiplying everything doesn't really affect anything. So it's just there, but we don't really need to worry about it. X plus 5, x minus 2. So I test some numbers in between. I find that any number between -5 and 2 in this equation gives me a negative value. That's what I'm looking for. Is it negative or is it positive? And it's positive on the outside of these two values, and it's negative on the inside. This parabola, if I was going to sketch it on the x-axis, would look something kind of sort of like this, right? And so the graph of that parabola would dip down below the x-axis between these 2 points. It's a positive parabola opening upwards, crosses the x-axis right here. So here's where the parabola is negative. That's what this is asking. Where is this less than 0 or negative? So the solution is just from -5 to +2 in this region right here. Now this one over here, do it the same way. Set it to 0. Find the two 0 points. All right, and in this case, this again factors pretty nicely to x plus 6 times x minus 1. We got greater than or equal to 0 here in this inequality. And so once again, it's negative in between these two zeros. because the parabola does this again. If the parabola was upside down, then it would go the other way, but in this case, it's still positive, and it's negative in between these and positive outside. But this inequality question is asking, where is this greater than 0? Where is it positive? It's positive to the left of -6, and it's positive to the right of +1. So there's my solution. X is less than or equal to -6, or X is greater than or equal to +1. And you do have to say it as two separate statements. You can't kind of turn the inequality symbols around and make it as one statement. That is actually an incorrect thing to say. So make sure that if your solution region is two separate spaces, then you describe them with two separate inequality statements. If it's a solid conjoined interval like this, then you can use this type of